Hello everyone. So we're going to be moving into chapter 10 next week, and so I wanted to have a brief pre-lecture tutorial to sort of explain the main idea behind chapter 10. And the main idea is basically bringing in one of the major cross-cutting concepts of all of science, and that's that the way that things work are deeply related to how they're put together. So basically there's a strong relationship between the structure of something and its function. And so that's also true when we consider substances and chemical reactions. And so now that we understand how atoms are put together and we understand their structure and the way that they function, now we're going to go on to the next level and talk about how molecules are put together and why they're put together in certain ways, and ultimately understanding how that structure impacts the function of the molecule as well. And so in order to understand how molecules are put together, we have this system which we call Lewis structures. And so I know that we've talked about Lewis dot structures in the past. So we've done the exercise a number of times where, say for example, if I were considering oxygen, okay, and I wanted to draw the Lewis dot structure of oxygen, then I would use the symbol for oxygen, the O, and then looking up oxygen in the periodic table, it's in group 16, and so based on what we learned earlier in the year, that we know that elements that are in group 16 have 6 valence electrons. And so what we would do is we would go and we would take dots and we would use those dots to represent the valence electrons for oxygen. And so if I wanted to draw the Lewis dot structure for oxygen, it would look like what I just drew in the upper right hand corner of this slide. Well, now we're going to go and we're going to start linking atoms together with these Lewis dot structures to create structures for molecules. And so there's a way to do this that's very methodical. I would encourage you to go through each of these steps for each of the exercises that we do in this chapter. It's awfully tempting to just sort of go right in and start drawing and connecting atoms together, but I think you'll find that if you do that, you're going to end up making mistakes, you're going to miscount electrons, and your structure is just going to be wrong overall a fair amount of the time. And so make sure that you're following these steps and you should be fine. So the first step is to determine the overall arrangement of atoms for a Lewis structure of a molecule that you're about to draw. Now, basically, the simplest rule that we're going to follow right now is that you're going to look at the formula and you're going to go and you're going to see which atom is present in the least amount. That atom that's present in the least amount, that's the one that goes in the middle of the structure. Now, there's a more concrete way to do it later, but for now, let's go ahead and use that premise. Now, you're also going to add up the valence electrons over the formula so that you can come up with a bank of valence electrons that you can use to draw your structure. I'll demonstrate this with an example later on. Then you're going to go and you're going to take your central atom and connect the remaining atoms to it using single bonds. Now, each single bond represents 2 electrons. Once you've connected everything with single bonds, then any electrons that are left over, you're going to start to distribute through the atoms in the structure. Now, the way to do it correctly is you're going to add the electrons first to the outer atoms of the structure. If there are any left over, then those would go on the central atom. Okay? Really, the best way to show you how this works is to actually do a couple of examples. So, suppose I wanted to draw the Lewis structure for ammonia. Okay, I'm going to look at the formula. Okay, now notice that there is 1 nitrogen in ammonia and 3 hydrogens. Since nitrogen is present in the least amount, there are fewer nitrogen atoms than there are hydrogen atoms, that's going to be my central atom. Okay, now I'm going to count my valence electrons. Now I'm going to break down the structure of ammonia to do this. I have 1 nitrogen and I have 3 hydrogens. Now, on the periodic table, nitrogen is here in group 15. So that means that nitrogen has 5 valence electrons. Now, hydrogen is here in group 1. And so that means that hydrogen has 1 valence electron, but there are 3 of them. So since there are 3 hydrogens and each one contributes 1 valence electron, then that means this Lewis structure will have 3 valence electrons from hydrogen, in addition to the 5 valence electrons from nitrogen, for a total of 8 valence electrons. So here is our bank of valence electrons that I'm going to use to draw this structure. Now I'm going to start putting it together. We said nitrogen is the central atom, so I'm going to put it in the center and connect the hydrogens to the nitrogen. Okay? Now, I've only used single bonds to connect each hydrogen to the nitrogen. Remember that I said that each bond is 2 electrons. So that's 2, 4, 6 electrons that we've used so far. So subtracting the 6 electrons I just used for the single bonds, that leaves 2 valence electrons left over. Now, normally I would add them to the outer atoms, but remember that hydrogen is a a period 1 element. If it's an element out of the first period, then because we're filling that 1s orbital that we spoke about in the last chapter, you can only have hydrogen have 2 electrons within its structure. Since each hydrogen is already bonded to the nitrogen, then that means that each hydrogen already has 2 valence electrons. And so you cannot add these remaining 2 valence electrons to any of the hydrogens because basically they are already full. The 1s orbital is already full as a result of the covalent bond with the nitrogen. The only other place that these 2 valence electrons could go would be on the central atom. So I'm going to draw a pair of electrons on the nitrogen, and that would complete my Lewis structure for ammonia. Let's try another one. Let's try phosphorus tribromide. So like I did the last structure, I'm going to look at the formula carefully. I have 1 phosphorus and 3 bromines. And so that means that since there are fewer phosphorus than bromines, that means the phosphorus is central. Okay, and I'm going to take apart the formula further. Okay, 1 phosphorus, 3 bromines. And if I take a look at phosphorus on the periodic table, basically it's in group 15, meaning that it's going to contribute 5 valence electrons to the structure of this compound. Now, there are 3 bromines, and if I look at bromine in the periodic table, it's in group 17. So that means that there are 7 valence electrons for each bromine. So if we add together the total number of valence electrons that we've counted up so far, 3 times 7 would be 21 valence electrons, plus the 5 from phosphorus, that gives us 26 valence electrons. And so I'm going to start putting the structure together. Again, we said the phosphorus would be central to the structure, and then I'm going to connect all of the bromines to it using single bonds. Again, each single bond represents 2 valence electrons. And so since I've added 3 single bonds to the structure, then I would be subtracting out 6 valence electrons, right, because of those single bonds that I've added to the structure. So now I have 20 valence electrons left over that I have to distribute. And so I'm going to go and start off placing them on the outer atoms. Now notice in this case, we have bromine as the outer atoms of this particular structure. And so bromine can have a full octet of electrons, since again, it's not hydrogen or helium. So I'm not constrained by the 1s orbital like I was for the structure of ammonia. And so as a result, I'm going to start adding up these 20 valence electrons, starting with the outer atoms. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now, notice that I'm still short of where to put the remaining 2 valence electrons. I've just added 18 valence electrons. There are 2 valence electrons left over, and I don't have anywhere to put them on the outer atoms. And so that means I must add them to the central atom, so that means those final 2 electrons should go on the phosphorus. It's also possible to draw Lewis structures for polyatomic ions as well, since the atoms within a polyatomic ion are covalently bonded to each other. And so you do that by following essentially the same set of rules that we have been following with just one minor modification. Take, for example, here, if I wanted to draw the Lewis structure for the hydronium ion. So if we take a look at the formula for the hydronium ion, we're still going to go ahead and determine which should be the central atom. So there's one oxygen, but there are 3 hydrogens. And so since there are fewer oxygens than hydrogen, then that means that it must be the central atom. I'm also going to start tallying up my number of valence electrons. So oxygen, once again, since oxygen is in group 16 in the periodic table, that would be 6 valence electrons. I also have 3 hydrogens. And so basically, each hydrogen would contribute 1 valence electron because of its placement in group 1 in the periodic table. And if you notice, this particular polyatomic ion has a positive charge. In order to create that positive charge within the structure, then I must subtract 1 valence electron because of that positive charge. And so if I go ahead and combine this total, that would be 6 plus 3 minus 1, that would be 8 valence electrons. And I'm going to go ahead and start assembling the structure. So I have oxygen in the middle, and I'm going to connect the hydrogens to the oxygen. Now notice that in doing that, I used 3 separate single bonds. And so because I added 3 single bonds, and each single bond represents 2 valence electrons, I've just used up 6 valence electrons. That means that there are still 2 valence electrons left to be placed in the structure. Again, since I'm filling up the 1s orbital for hydrogen and no more, basically the connection of each hydrogen to the oxygen via the single bond already fills that 1s orbital. So these 2 valence electrons cannot go around the hydrogen, they must go around the central atom, and so that means I must place these 2 valence electrons on the oxygen instead. Now to finish the structure for a polyatomic ion, it's customary to use square brackets and then place the charge of the ion in the upper right hand corner. Let's do one more, and this time we're going to do one that has a negative charge. So I have the hydroxide ion here. Now the question of which atom is central is sort of an unnecessary question because there are only 2 atoms in this particular structure, and so they'll simply just be connected to each other. Now I'm going to start counting up my number of valence electrons. So I have oxygen, and oxygen has 6 valence electrons, as we've discussed before, and hydrogen would contribute 1 valence electron. But notice that here, this particular polyatomic ion has a negative charge. And so that means that since I have a negative charge, then I must add 1 more valence electron. And so if I go ahead and combine 6 plus 1 plus 1, that's another 8 valence electrons that will be associated with this particular structure. So I'm going to connect the oxygen to the hydrogen. By connecting those 2 with a single bond, I've used up 2 valence electrons. Okay, so if I subtract that out, that means I still need to place 6 valence electrons within this structure for the hydroxide ion. And so if I go ahead and consider where to place them, I can't place them around the hydrogen, since again we're limited by that 1s orbital for hydrogen, so that means it has to be placed, or all of these 6 valence electrons have to be placed around the oxygen. So that would be 1, 2, 3, 4, 5, 6. And then to finish the structure of this polyatomic ion, I'd enclose it in square brackets and place the charge, once again in the upper right hand corner. In this case it would be a negative charge. Okay, so go ahead and work on the follow-up assignment to this tutorial. Again, if you have any questions, by all means email, and also if necessary, ask your questions in class. We will be reinforcing this skill for the next few days or so. All right, have a good night.